All right, here we go. Question 17 from our Precalculus homework number 1 in MyLab Math. And it's a word problem. A golf ball is hit with an initial velocity of 150 feet per second at an inclination of 45 degrees to the horizontal. In physics, it is established that the height h of the golf ball is given by the function. Here we have a function given to us, where x represents the horizontal distance that the golf ball has traveled. What does h of x represent? H is the height. X is the horizontal distance. So part A says determine the height of the golf ball after it has traveled 100 feet. So that would be a horizontal distance of 100 feet. Which means we need to replace x in our function with 100, and that will give us the height of the golf ball at that point. So here they want me to calculate h of 100, which means I'm going to replace every x with 100. And then what a fantastic time to have a calculator. So on our Casio ClassWiz, we're going to input this calculation all at one time. We're going to use our fraction button and the negative button. Negative 32 times 100 squared all over. Notice I hit the over arrow to move down. 50 squared. We're going to move out from underneath the fraction and put plus 100. And notice that the ClassWiz gives us an improper fraction. I believe what we would like to have is a decimal rounded to 2 decimal places. So we're going to have to hit the SD button. Rounded to 2 places would be 85.78 is the height of the golf ball after it travels 100 feet. Next, what is the height after it has traveled 250 feet? Same song, second verse. Now, if you have the ClassWiz, you can simply backtrack and replace the 100 with 250. Every x now needs to be 250, so we're going to replace each one of the 100s with 250, and then this would represent the calculation to get the height of the golf ball after it travels 250 feet. Again, we need to hit the SD button to get a decimal approximation. Rounded to 2 decimal places would be 161.11. 161.11 feet high. Oh my gosh. Okay, one more time. H of 350. Bringing up the calculator again. Back. So now instead of 250, we're going to delete and have 350. And don't forget to change this guy too. 350. How high is it? It is about 175.78 feet. Rounded to 2 decimal places. 175.78 feet. Now then, it says interpret the value of h of 350. Choose the correct answer below and fill in the answer box to complete your choice. All right, so what are the options here? It says the height of the golf ball after it has traveled a horizontal distance of 350 feet is, that's what we just calculated. Part B, at a height of 350, no, that's not correct. Right? Because it says h of 350, where the 350 represents x, where x is the horizontal distance, not the height. So it's going to be A. And how many feet was it? I think this is just going to be copy and paste. 175.78. Yeah, just copy and paste the previous answer. How far was the golf ball hit? How far? Well, x is the horizontal distance, which means we would need to solve for x The question is, think about this. If I hit a golf ball, let's draw a picture. My little golf ball club. If I hit a golf ball, I think it's set at an inclination of 45 degrees. Whatever goes up must come down, correct? And the total distance that golf ball has traveled is going to represent the distance from when I hit it to when it hits the ground. So we know that the height is going to be 0 when it has traveled as far as it's going to go. So how far was the golf ball hit? Well, I'm going to need to replace h of x with 0 and then solve for x. And that's going to take a little bit of work. So here I've got my equation set up where h of x has been replaced with 0, and I would like to go through and solve for x. And so I think the first thing I would like to do is to get rid of the fraction. The way I can do that is I can multiply both sides by 150 squared. On the left-hand side, 0 times anything is still going to be 0. And that means I'm going to have to distribute this 150 squared, which is going to cancel this guy out, leaving negative 32x squared, plus, but this is going to be 150 squared x. And then, let's see, I think I can solve this now by factoring, because both of those terms have an x. I can factor out an x. So that'll leave me negative 32x plus 150 squared. And then I can set each factor equal to 0 and solve. Obviously, the first answer, where x is 0, that's going to represent the initial hit. Like the ball was still on the tee. It hadn't traveled any distance. This other solution, negative 32x plus 150 squared equals 0, this is going to represent the total distance traveled. So we're going to move our 150 squared over. Negative 32x equals negative 150 squared. Divide both sides by negative 32. And then whatever that works out to be is going to be the answer for the horizontal distance. So we're going to input this in the calculator. Wait a second though. Negative over a negative makes a positive. So I don't really need to input the negatives. I just need to do as a fraction 150 squared over 32. And then I need to hit the SD button to get the decimal approximation. How far was the golf ball hit? Round to 2 decimal places. 703.13. Enter. Next part, use a graphing utility to graph the function. Choose the correct graph below. They're telling me the settings for my graphing calculator. And then they want me to choose the correct graph based on these particular window settings. Now, I don't have a TI-84, but what I do have is Desmos. Okay, so I'm going to use Desmos.com to graph this particular function. In Desmos, in this bar here, we can type in h of x is, and to input a fraction, we're going to use the divided by. That'll set up a fraction. Negative 32, we can say x squared, clicking on the bottom, 150 squared, and then plus x. And in Desmos, notice it looks almost like a straight line. It's not linear, obviously it's quadratic. But now we're going to set the window in Desmos, the x's from 0 to 800 and the y's 0 to 180. And the way we do that is with the little graph settings wrench. The x-axis, we're going to change that from 0 to 800. And the y-axis, we're going to change that to be 0 to 180. And then that gives us a picture of what the graph's going to look like. And then all we need to do is pick the graph that looks like this. Notice that this graph doesn't go nearly as high as this one does. This graph over here in this window setting goes almost to the very top of the window. So that's looking a lot like this answer choice. And both of these end at about the same place, but they don't go nearly high enough. It's got to go almost to the top of the window. I think it's going to be answer choice B in this case. Part F, using the graphing utility, determine the distance that the ball has traveled when the height of the ball is 100. So we can come over here to Desmos, and if we click on this graph, we're looking for a y value of 100. Remember, in this graph, the y is how high. So at 100, and it's going to be hard to figure that out exactly. So the way we can do that exactly in Desmos is we'll just type in the equation y equals 100, and then where those graphs intersect, look at that, is going to give me the x-coordinate where the ball is at a height of 100. Notice it does happen twice. After the ball has traveled 120.73 feet and 582.40 feet. If we round that to 2 decimal places, yeah, the ball has not traveled. Yeah, the ball has traveled. It says use a comma to separate your answers. Okay, so the first answer was 120.73 feet and 582.40 if we round it to 2 decimal places, which is what it requests. And then it says create a table with the table start equals 0. I think this is referring to a TI-83 or an 84 graphing calculator. To the nearest 25 feet, how far does the ball travel before it reaches a maximum height? What is the maximum height? So here on this graph, we're looking for where it reaches its maximum height. Notice Desmos simply requires that you click at the vertex where the maximum height is. Desmos is going to give you the vertex. So the 351.56 is how far it has traveled. The 175.78, that is how high it is. Okay, so then in our box here, to the nearest 25 feet, we're going to be able to get to the nearest hundredth of a foot. The ball has traveled 351.56. Wait a second, to the nearest 25 feet. I think that's telling me where to round to. To the nearest 25 feet, that would be 350 feet. If I round to the nearest 25 feet, let's check and see if that's what it wanted. Yes. So be careful there. It's telling you where to round. Now the maximum height wants the exact height to 2 decimal places. And that's going to be 175.78. Bam. Adjust the value of delta t. Again, this is talking about TI-84 stuff. To within 1 foot, the ball travels before it reaches a maximum height. Again, we can do that because we have our Desmos window open, and it wants it rounded to the nearest whole number. How many feet? That's 352 feet, rounded to the nearest foot. And I believe that's going to do it for this particular problem. So if you have any questions or comments, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.